All right, the big kahuna, the advanced topic. This one is meant to really test you, so don't be afraid if it gets a little difficult. It's going to take you some time. This topic alone, I think, is slated to take 21 plus minutes. So again, sit in it. Don't be afraid of it. Okay, so again, these ones are overlapping. So you're going to have to go ahead and draw them separately. So we're given that PT is equal to RS. So I'm going to mark those, PT and RS. And angle P is equal to angle R. And they want us to prove that PQS, so that's this one, is equal to RQT. That would be right here. Okay, so there's our overlapping triangles. Now, first thing I'm going to look at, those overlapping triangles, they don't have any overlapping angles per se, no overlapping sides per se. They do have, however, that like angle 2 is in both and side TS is in both, which we have seen in MT2 when we did proofs. So we can keep that in mind because we might use some of those skills, okay? Which we very well will. Okay. Okay. So I'm going to go ahead and draw some of these. Let's see. So we've got this guy. Goes this way. PQS. And it's got also a point T here. And then, let's see. Like that. QTR, little point S down there. All right, and we know that R and P are the same. And that distance from here and here are the same. Okay. We also know that this and this are the same. So by looking at it, we do know, this is kind of a fat pen here, let's see, that this distance across here is the same as well. So we've got those two the same. So right now we only have two pieces that are the same, and that can feel really kind of scary because what else is the same here? So, But here's something I want you to look at. I'm going to kind of highlight this. I'm going to erase this line in here. Okay. Look at that. And look at the original triangle. If I were to get rid of these marks and this, what kind of triangle does that look like? If we just knew that P and R were the same, that is an isosceles triangle. Okay? I hope you're seeing that. This is an isosceles triangle. And when that's true, we go across and these are the same. Okay? You kind of have to fight through and you have to visualize it in your head there, but yeah, we got those. So if we know that PQ and RQ are the same, PQ is congruent to RQ because of isosceles triangle theorem. So we're going to mark that on here. Here we go. So now we can see that we've got that we have a side angle side congruence. If we can prove that PS is congruent to TR. And we have done that before. Like I said, back in MT2, you were able to prove whole segments were congruent to whole segments by segment addition. You've got to bring that math and bring that skill back, okay? So let's go practice that. Let's see what we remember. Oh my goodness, it's gonna hurt our brains. We got this. Okay, I'm bringing my keyboard back out, and let's go. We got this. Send to proof. We got this. All right, measure of P, measure of R. Let's do the easy one here. Let's do PQ and RQ. We will say that PQ is congruent. Nope, that's not a congruent. Congruent to RQ by, let's go find those isosceles theorems that they give us. It's going to be one of these two in here. We've got, if two sides are congruent, then the angles opposite those sides are congruent. Are we proving angles congruent? Nope. If two angles are congruent, then the sides opposite are congruent. Yep, that's the one. We're proving the converse property. There it is. Woohoo! All right, so we've got two of the things that we need. Now we need to prove that PS and TR are congruent. PS and TR. So in order to prove that PS and TR are congruent, that's our goal, PS and TR, we have to get them into the actual proof. So let's start by getting that in there. PS is equal to what? PS is equal to PT plus TS. So it's equal to PT plus TS. Okay? That is segment addition. Where's segment addition in here? Did I pass it? I might have. Segment addition property. There we go. Okay. PS is in there now. We also need TR in there. TR is equal to TS plus SR. TS plus SR. By segment addition also. Okay. Now we need to say that those are equal. Okay? And I want to show you this. Just remind you guys what this looks like. When we say PS equals PT plus TS and TR equals TS plus SR, the only way we can put this up here is by substitution. That's the only way. All right? And this is already there. Okay? So we're almost there. Is SR the same thing as PT? They tell us it is. So our next step, we need to say that TR is equal to PT plus TS by substitution. So we can then put this up there, okay? So we can put this in its place. I hope that kind of makes sense. That's going to be our next step that I'm doing next in the proof. Okay. Oh. So TR equals PT plus TS. And the reason, we're just going to substitute out the SR for PT. And we can do that because our given was that they are substitutable. They are the same thing. Oh, what did I screw up? PT is equal to RS. TR. Uh-oh. They don't like that. Goodness. PT plus TS. Well, did I leave a space in there somewhere? Did I get all my givens in? PT plus TS. Well, they're not loving me. Okay, well, we're going to do it the other way around then. We're going to try this. Maybe they don't love that I put in the RS backwards. And let's try it the other way. Equals PT plus TS. Okay. That is very crazy. They wanted the RS to be in the right order. I've not had ALEKS get mad at me for that before. That's something new. Interesting. All right. Now, if you look at lines 4 and line 7, PT plus TS, both PS and TR are equal to the same exact things. So now I can set them equal. So PS is equal to TR. That's what I'm going for. PS is equal to TR by substitution. No whammies. There we go. Woohoo! Whew. We got there. And now I can finally say that those triangles are congruent by side angle side. My proof is complete. And we're going to check it. Ah, that explains it more. I was having an issue. All right. Well, good luck with your proofs. May the odds be ever in your favor.